Yeah. So is it my slide is visible to everyone?
Yes, sir. It's visible, sir.
Okay. Thank you so much for the confirmation. So today we are going to start the unit number 5. So power and energy management system. Just 1 minute. So class number 15, and today is the 28th July. So in the previous class we discussed about the battery management system. So in the last class we discussed the size the fuel cell plant. So how we can decide the size of the fuel cell plant and balance of the plant and hydrogen storage system. So in the last class we discussed the total four topic, and last one that is a supercapacitors for the transportation applications. So is there any confusion, any query from the previous class? Yes, any student? So in the last class we discussed the theory as well as the few numericals. So you got the better understanding. So in the today's class we are going to start the fourth unit, that is your uh, power and energy management system. Okay. So starting with the fundamental, there is a key function block of the electric vehicle power management system. So how we can manage the power, and there is a key block diagram, otherwise the key function. And then we will discuss the types of the power management system. Okay, so these two topics we are going to discuss in the today's class. So energy and power management both are the different thing. So energy, we know energy is nothing but what we can do, correct? So what it is a capacity of the work. So what is our capacity to do the work? It is our energy, correct? And power is nothing but energy into the time. So how much time it will take to do the work, that is your power. Okay, so it is a simple energy means capability to do the work, that is energy, and power means how much time it will take to complete this task, that is your power. So we have to manage the both, that is energy as well as the power. There is energy and power management for the EV. So effective energy and power management is a crucial in the electric vehicles. And why crucial? Because we want the maximum driving range. Yes, all the customer, all the car drivers want the maximum driving range with the single charge of the vehicle. Maintain performance, yes, everybody want like noiseless operation, vibrationless operation. So maintain the performance. Ensure the safety, yes. So there is a main concern from the customer side. So they are maybe the struggling with the blast, maybe the replacing of the battery, maybe the resale of the vehicles. So ensuring the safety, battery longevity. So life of the battery there is a long, correct? So because of these four reasons, energy and power management that is the most crucial part in the electric vehicles. So maximum size, maximize driving range, maintains performance, ensure safety, and better battery longevity. Correct. This it involves controlling how energy is stored, distributed, and utilized among the different subsystem of the electric vehicles. So main concept is we have to store the energy, correct? So first one that is a store the energy, we have to store the energy. So how we can store the energy, correct? We can use the battery, we can use the supercapacitor. Second one, distribute. So whatever energy we store, so how we can do the distribution in the better way. There is a distribution and then utilize. So whatever distributed energy, that energy must be utilized. Okay, among the different subsystem. So this is the key block diagram of the energy management system. So we can say energy, it is nothing but battery. So we can say this is the battery components, and we have to manage this battery. So that's why we can say the battery management system, that is the most important part. because this battery management system, it is a manage the all the components, maybe the SOH, SOC, SOT, any temperature, any parameters, all the parameters that is managed by the battery management system. Electric motor, because we have to give the some power to the electric motors. Auxiliary load, we have also auxiliary load. DC-DC converter, low voltage system, because somewhere we have to use the high voltage, somewhere we use the low voltage. Low voltage systems, AC and DC charging system, onboard charger. So this is the overall energy and power flow in the electric vehicles. So basically source is your battery, and then battery, from the battery we can distribute the power from the to the different subsystem. Okay. So key components in electric vehicle energy system. So battery pack. So role is to store the electrical energy. Usually we can use the lithium-ion battery. Yes, solid state battery. Still, it is a research topic. Battery management system, that is a heart of the vehicle. So we have to monitor and protect the battery parameters. So there is a temperature, SOC, SOH, and etc. etc. So there is a battery management system. Electric motor and motor controller. So second hearts, we can say it is a electric motors and the motor controller. So converts the electrical energy into the mechanical power, because ultimately we have to produce the mechanical power. Inverter convert the DC to AC. So maybe some load that is a AC. So something like the PMSI motor, it's required the AC supply. So maybe the few loads carry the AC supply, then we have to use the inverter. Regenerative braking. So recover the kinetic energy during the braking. So while applying the braking, we can produce the energy, and that energy we can say kinetic energy, and that kinetic energy we can convert into the electrical energy. So we can say recovers the kinetic energy during the braking system. Charger and the charging system. So what type of charger we have to use, and what type of typical charging system it is required to charge our vehicle. So manage the power input from the grid. So we have to manage the power input from the grid. So that is a role, and that is the main components is charger and charging system. DC-DC converter. So because some load is a DC and some load is AC, so that's why it is required the inverter as well as the DC-DC converter. So step down high voltage to power the low voltage system like light and infotainment, and so like very low voltage DC supply required the DC-DC converters. So these are the major key components for the energy and power management. So power management strategy. So how we can able to manage the power. So power management involves the optimizing energy used during drive and charge cycle. So first one, there is a drive cycle management. So we have to manage the drive cycle. So how you are able to drive the vehicle. So there is a eco mode, otherwise the power mode. So adjust the torque and speed to save the energy. So normally we can say, suppose you are stop on the signal, then we have to cut the fuel from the vehicle, correct? Otherwise we can say the turn off the vehicle, so we can save the energy. So we have to adjust the torque and speed to save the energy, correct? So there is a eco mode, otherwise the power mode. Motor control algorithm optimize the efficiency under the different loads. So we have to check the different condition, there is operation of the different condition, and then we have to optimize the efficiency under the different load. Regenerative braking optimization adjusts the regenerative intensity based on the speed and battery SOC, correct? Then we can say we can optimize the regenerative braking system. Okay, so this is the part of the driving cycle management. Battery energy management, state of charge monitoring. In the second unit, we already discussed the SOC, SOH. So state of charge monitoring to prevent the overcharge and discharge. Thermal management. So ensure the battery operate within the safe temperature limit, maybe the 125 degree, maybe the 75 degree. So that is within the range of the operation. SOH estimation, maintain the long-term battery performance. Suppose your SOH is very good, so maybe your batteries operate very long time. Load management. Auxiliary load, AC, infotainment, light are managed to reduce the drain on the battery. So we have to manage when we have to operate the auxiliary load. Correct? So auxiliary load means your entertainment devices. Okay. DC to DC converter are used to manage the different voltage level efficiently. Correct. So that's why we have to use the DC to DC converter, and that is your under the category of the load management system. So energy efficiency optimization. So how we can do it? So routing planning. So normally we have to do the routing planning. So minimize the energy consumption using the GPS and traffic data. Correct. So we have to use the latest technology to manage the energy. So we will get the better efficiency. Eco driving behavior. So normally we have to use the eco driving. Okay, so suppose your road is empty, then we can use the eco driving mode operation. Smoother and acceleration braking save energy. Okay, so suppose you drive your vehicle on the eco driving, then you will get the better efficiency. Thermal preconditioning. So heat, cool the battery and cabin while plug in. Correct. So we have to manage the thermal also very well, so that will not affect on the battery. Energy harvesting, regenerative braking, and solar integration in the electric vehicle. That is the most important part for the energy harvesting. So we can harvesting energy in the two way. First way, that is a regenerative braking, and second way, that is a solar integration. Okay, so this way we can save the energy and we can get the maximum efficiency. Smart energy management with the AI and machine learning. So nowadays there is a hot topic. So we have to use the artificial intelligence technique, otherwise the machine learning, so we can get the maximum efficiency. So modern electric vehicle and hybrid vehicle use the machine learning, AI and machine learning algorithms for predictive energy use. So we can predict the energy use. So next 30 minutes, how much energy use? Maybe the next 1 hour, how much energy will use? Driver behavior analysis. So we can also see the driver behavior. So maybe the driver is expert to drive the vehicle, maybe he is average, yeah, what. So driver behavior analysis. Adaptive charging scheduling. There is a smart grid integration. So normally people charge the vehicle in during the night time, so they have to pay the less amount. Otherwise, during the morning time to evening time, there is a peak load demand. So you have to pay the more amount for your charging. Okay. Fault detection in the energy system. So we have to identify the fault, correct? So and that is nothing but under the predictive energy use. Otherwise, we can say the predictive maintenance. Okay. So before the happening of the fault, we can identify the fault. Then we can say it is a predictive maintenance. Okay. Challenges in energy and power management. So what type of challenges we are facing nowadays? So there is a balancing performance with the range. So we are not able to balance the energy with the performance. Okay. Managing the battery degradation. So battery degradation is a very fast because driving cycle is not very well maintained. So that's why battery degradation is very fast. So how we are managing this battery degradation? That is also challenges part. Efficient thermal management in the varying the climate. So how we can manage the thermal property? Because nowadays India also per day we are feeling the three season: monsoon, summer, and the winter. Correct. So how we can manage the temperature of the battery? Otherwise, the overall device of the battery, overall device. Correct. Last one, there is an integration with the renewable energy and smart grid system. So how we can do the integration with the smart grid, otherwise the renewable energy system. So we have to pay the less amount of charge. Okay. So these are the challenges in the energy and power management. So these are the detailed discussion. So what is a battery energy utilization? So determine the how much energy is drawn during the acceleration, cruising, and regenerative braking. So battery energy utilization is nothing, but we have to identify how much energy that is utilized. State of charge monitoring. Normally we can say SOC monitoring. Maintain the battery SOC within the safe limit. Typically, there is a 20 to 80% to prevent the deep discharge, otherwise the overcharge. That's a SOC. So detail of the SOC we already studied in the second unit. Thermal management, control the battery temperature to prevent the overheating and maintain the efficiency. So that's a thermal management. Driving mode selection, maybe the eco mode, maybe the normal mode, maybe the sport mode. So any mode you can select and you can save the energy. Regenerative braking. Normally we are applying the braking in the any condition, correct? So recover the kinetic energy during the braking and convert it back into the electrical energy to recharge the battery. Okay. So by using the regenerative braking, you can recharge your lithium-ion battery also. Okay. So, but main issue is the synchronization. So how we can synchronize the power supply. Then power management, so traction power control. Okay, so we have to control the power of the motor, and motor is nothing but your traction. So supply required power to the electric motor based on the driver input. So maybe the accelerate, maybe the torque demand. Okay, so depend on the customer demand, we have to manage the power. Accessory power allocation. So manage the power for auxiliary load. There is ISO, infotainment, light without compromise the driving range. So we have to manage the auxiliary load without the compromising of the driving range. Okay. So there is a accessory power allocation. DC to DC conversion, there is a simple because we have a DC supply, and suppose you want to change the level, maybe the 10 volt to the 20 volt, maybe the 400 volt to maybe the 1800 volt. So then you can use the DC to DC converter. So you can see this is the 400 to 800 and 12 to 48 volt. Load balancing. So prioritize critical system. There is a motor control, safety electronics over the non-critical load. Under the low SOC condition, there is a state of charge condition. And finally, charging power control. So we have to manage the AC to DC charging rate and ensure the safe grid interaction. Correct? Otherwise, suppose you are not taking any power from the grid, so maybe your charger is not working properly. Correct? So we have to see the proper management between the grid and the charger. Yes. Till now, any query, any confusion? Before going to the next topic, any confusion? Yes, student.
Sir,
Yes.
what is active cell balancing? Sir?
Yes. Good. Any other query? Active cell balance is very good.
No, sir, no.
Yeah. Active cell balances means, so normally battery pack is designed by the combination of the cell, correct? So normally we can say this is the battery pack, and we can say this is the combination of the cell, series and parallel. One, two, three, four, five, six, seven, eight. 1 and 2. So we can say the 8 series serial and parallel 2. Correct. So we can say series is 8 cell. So we can say 1, 2, 3, 4, 5, 6, 7, 8. So 8 cell there is a connected in series, and parallel there is a 2 cell. Correct. So active cell means we have to charge all the cell. 1, 2, 3, 4, 5, 6, 7, 8. All the cell we have to charge the similar way, otherwise the parallel way. It is your active cell balancing. It is a not like that you want to charge your cell number 1 and cell number 6. It is a not like that. You have to charge the all the cell in the parallel at a time. Okay, then we can say it is a active cell balancing. So whatever cell available in the battery pack, all cell have to synchronize for the charging and the discharging. It is a not like that the 50% cell we have to discharge and 50% cell we have to charge. It is a not like that. All cell have to charge and discharge in the same manner. Then we can say it is a active cell charge technique. Okay, and that is a one of the good research topic. So
Yes, sir.
how you can manage the actively charge the all the cell.
Sir, what are its advantages? So the and in modern EV, these are trending
Yes.
towards new.
So suppose you are balancing the actively balancing the all the cell, so you can increase the life of the battery. Correct. So directly advantage of the active cell balancing, you can increase the life of the battery.
Okay, sir. Okay, sir.
Because battery is nothing but combination of the cells, correct? It is a series and parallel combination of the cells. And suppose you are not managing the cell, then ultimately it is a decrease the life of the battery. Correct? And that is a good research topic. Suppose somebody want to do the active cell balancing, that is a very good. But that is a like purely it is a chemical side, because we can, because it is a property of the chemical, so more work on the chemical side, chemistry person. But suppose somebody want to do the research on the active cell balancing and they are interesting, then it is a very good. Any other question from this topic, that is energy and power management?
Sir,
Yes.
actually, what is the difference between power and energy management in case of interconnection? In case of bilateral interconnection system like Nepal and India, sir?
Yeah, so there is a simple. So before going to technical, I can give the simple example. So energy and the power, you know, correct? Definition, you know, correct? In the simple word, energy is nothing but we have to do the work. That is your energy, correct? There is a capacity of the work, correct? And the power is what? So how much time it will take? Suppose I can say I can teach electric vehicle maybe the 6 month, and suppose some faculty member can say I can teach this electric vehicle subject within a 1 day. So work is a common, so you have to teach the subject of the electric vehicle, correct? So that is your energy. So we have a capacity to teach the subject. But another point is how much time it will take. So one faculty maybe take the 1 semester, so there is a 6 month for the same subject, and one faculty may be complete within the 1 month for the same subject. So that is your power. Correct? So there is a energy is different and power is different. So there is a fundamental concept. Now, both are the management. So we have to manage the energy as well as the power. Manage means suppose we have a one syllabus, one subject, and we have to complete this subject. So maybe you can put your whole energy for this subject. Otherwise, maybe you can distribute your energy, correct, for the different subject. Maybe one subject is electric vehicle, maybe another subject is FPGA, maybe third subject is a power electronics. So you can manage your energy. You can give maybe the 1 hours for each subject. So that is your energy management. Power management is you have to manage your energy plus time. Both things you have to manage. So that is your power management, because you have to complete your task within the timeline. Now I can come back to your question. There is an energy integration between the Nepal and the India. So I am not sure about the this situation because I don't know really energy's integration with the Nepal and the India. Do you know any idea about? So is it really interconnection between the Nepal and India for the energy?
Power is exchanging, sir, from India
So
and Nepal nowadays. Now,
so that is
nowadays.
available. The system is available to exchange the power from India and Nepal.
Yes, sir. We have a Dhalkebar Muzaffarpur transmission line. From that, uh, uh, we were we were taken power from India uh,
Important.
during the dry season,
Okay, okay.
and in the wet seasons, we are capable of delivering some amount of power.
Yeah, because you have a hydropower plant, correct?
We have abundant in hydropower, sir. Hydropower in Nepal.
A hydropower plant not available.
Yes, sir. Abundant. We have abundant sources of
Yes, yes, yes. That's why
hydropower
I'm
in
saying
Nepal,
yes,
sir.
yes, 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 yes. So in that case, we can say yes if you know that is available integration of the Nepal and India, then I can say power management is what. So as you said, so in the dry condition, you have to purchase the power from the India, and during the monsoon season, you are able to deliver the power to the India. Correct? So, as per my knowledge, as per my understanding, so what we can do in the power system, power management. So, suppose you are able to deliver the power 100, so no 100 megawatt is too much, maybe the 1 megawatt per day to the India, correct? So, suppose you are selling the power 1 megawatt per day to the India, then how India will able to manage this power because this power is directly coming from Nepal to the India. So maybe this India will distribute this power to nearby the village, maybe the nearby the state, correct? Otherwise, suppose they are not managing the power to nearby the state, otherwise the nearby the village, then where they can use this power. So there is a power management. So maybe the from 1 megawatt, maybe the point 0.5, maybe the 10 kilowatt they will give to the one village, maybe the 20 kilowatt they will give to the two village. So something like that. So they will distribute the power to the different manner, and that is your power management. As per my understanding, that is a practical situation for the Nepal and the India. Got it?
Okay, sir. Got it.
Got it. So ultimately, there is a manage the power. Suppose you are sending the power from Nepal to India. So how India will manage that power? Correct. So ultimately, they have to send power. They have to distribute the power. And suppose you are sending the power from Nepal to India, then how you will fulfill the demand? Correct. So suppose maybe you have a over power, then you are sending the power. Maybe sometime you want the amount, so that's why you are sending the power. Correct. So for the Nepal, you can cut down the power and you are sending the sell the power to India, and India will give the amount. So there are the many conditions, but ultimately we are discussing the management. Correct. So how you are manage the power, that is the main thing. Okay, because we cannot store the power too much because this is AC, so we cannot store the power too much. At a time we have to use this power. So we have to ultimately distribute the power in the different manner. So maybe in the village, maybe the city, or somewhere else. Got it? Yes. Any other confusion? Any other query? Okay. Now next topic, there is a types of the power management strategy. Just 1 minute. Yes. Types of the power management strategy in the electric vehicles. So power management strategy is defined how electric vehicles allocate and control the energy to ensure the optimum performance and extended the range and battery safety. So that's why we have to apply the strategy. So we can say, suppose I want to become the success in the academic field. So what type of strategy I have to apply? correct? So to become the success in the academic field. Suppose you want to become the success in your job, correct? So what type of strategy you are applying to become the success? So same in the technical field, in the electric vehicle. So how we can manage the power to become the success? In the become the success in what sense? To ensure the optimum performance. So we will get the optimum performance, extend the range and battery safety. Correct? So suppose you will get these three features, then you will become the success. To achieve this success, what type of strategy we will implement? So total 5 strategy. First one, there is a rule-based power management. So we will make the rules, correct? And that is based on the rules, we can implement our strategy. Second one, optimization based management. So we can use the optimize, correct? Fuzzy logic, heuristic, otherwise the fuzzy logic strategy. Fourth one, there is a machine learning and AI based. And fifth one, there is a hierarchical power management. So rule-based power management is simple. You can compare with our life. Suppose we can say my rule for my best life is I can save my amount. Maybe the per day, maybe the 100 rupees, yeah, maybe 200 rupees, correct? So that is my life rule. So ultimately after 20 years, I will get around like 50 lakh rupees. Okay, there is a rule base. Optimization base means whatever our demand, we can utilize, there is a minimum, that is your optimize, correct? So you can optimal use of the that amount. Suppose you want for your daily purchase, suppose you want 100 rupees, but some item you can delete from your list. So you can say from 100 rupees I can buy only 90 rupees and 10 rupees I can save. So that is optimal use, correct? Fuzzy logic strategy means maybe somewhere you can use and maybe somewhere maybe you cannot use. That's a fuzzy logic. Machine learning and AI based. So depend on your previous experience, depend on your previous expenditure. You can predict the data. That is your AI and machine learning base. And last one, that is your hierarchical power management. So depend on the chain sequence, depend on the previous data, you can continue that system, that is strategy, that is your hierarchical power management. Okay, so this is a simple is a common man language meaning of the different strategy. There is a rule base, optimization base, fuzzy logic base, machine learning and AI base, and hierarchical power management base. So let's see, we can discuss with the technical language.
Sir,
Yes.
one more time explain about fuzzy logic, sir. What is fuzzy logic, sir?
Yes, fuzzy logic means we have a condition. Uh, in the first semester or second semester, you not heard this name in the power system.
No.
So fuzzy logic, we have a truth table. So we have a condition. So this is the yes, no, maybe, may not, correct? So we have a condition. So same like here, yes, no, maybe, maybe not. So we have this type of table. There's a truth table, and depend on this truth table, we have to fill the data. So suppose we have a 1,000 data. Suppose we have a 1,000 data, otherwise 10,000 data. And based on this data, we have to fill the table. Yes, no, maybe, yeah, may not. So there is a fuzzy logic strategy. Okay. So for the better understanding, what I can do, so I will do one simulation. So same like the PI controller, correct? So we are using the PI controller to reduce the error. Correct? So why we are using the PI controller? PI controlling used to reduce the error. So fuzzy logic also same work. So they have to reduce the error. So suppose you have a 10,000 data, correct? So you have to put all the data in this condition: yes, no, maybe, may not, okay, and then finally you will take the decision. So which data is a minimum, and then you have to select those data. So that is a ultimately fuzzy logic. Got it?
Yes, sir.
Yeah. So for better understanding, what I will do. So you maybe already implemented that BLDC simulation part, correct? You completed that BLDC motor simulation part. Yes. Yes, please let me know. You completed already BLDC simulation part?
No, sir.
Yes, yeah, no.
No, sir.
No. Okay, no issue. So in the BLDC simulation, I use the PI controller, correct? So instead of the PI controller, maybe you can use the fuzzy logic controller. Okay. So same work. So PI controller is reduce the error, and fuzzy logic controller also reduce the error by table form, correct? So for the better understanding, I will also send the simulation using the fuzzy logic. So you will get the better understanding. Otherwise, I will send just research paper. So you will get the more knowledge. But fundamental logic is something like this. Yes. Any other confusion?
No, sir.
So rule based means use the predefined if and then logic or fix the threshold. As I said, so we have to design the rule for our life. So I have to do this work, I have to do this work. So based on this rule, you can do your work, correct? So use the predefined if and then logic and fix the threshold. Example, switch to regenerative braking when brake pedal is pressed. Okay. So I can say simple language. You have to study. Suppose you want to pass. Suppose you want to pass, then you have to study. It is the same. So that is a rule base, correct? Otherwise, we can say the condition base. Advantage is simple and raw computation cost. Yes, it is a very simple. Once you design the rule, then it is working very well. And low computation cost. Limitation, not adaptive to change in the condition, may be the less efficient. Because that condition is limited, maybe the 5, maybe the 6, maybe the 7 condition. So for those conditions, we have to work. So there is a like we can say it is a very less efficient. So there is a rule based power management. Optimization based power management, use the mathematical model, because we have to do the optimization. So we have to use the mathematical model to minimum, otherwise the maximize the objective. Okay. Method is dynamic programming, so we can do the dynamic programming, otherwise the model predictive control. Otherwise we can use the model predictive control to optimize the power management. Advantage is a high efficiency, yes, of course, because we are using the more data, so that is your more efficiency. Can handle the complex scenario. Okay. Limitation, computationally intensive and acquire the accurate model. Yes, because we have more data, so it is a computationally intensive and require the accurate models. Fuzzy logic, use the expert knowledge and fuzzy rules to make the decision. As I said in the previous slide, so in the tabular form, so you have to get the decision. So based on your expert knowledge and fuzzy rule base, we have to take the decision. Maybe yes, maybe no, maybe yes, yeah, no. Correct. Adjust the motor power smoothly based on the SOC and driver demand. Advantage, flexible, robust to uncertainty. But limitations, performance depend on the rule design and tuning. So as I said, so normally we use the PI controller, correct? So PI controller is what? That's a tuning. So we have to tune the KP and KI gain value. Here is also same in the fuzzy logic. So we have to tune the model, correct? So there is like yes, maybe no, maybe yes, correct? So we have to set the parameter, and then based on this condition, we can operate the model. There is a fuzzy logic. Machine learning, maybe all of you know this machine learning base. So you have a huge amount of the data, and based on that data you can predict the model, correct? So learn from the data to predict the optimum power flow dynamically. Technique, reinforcement learning, neural network. So many methods are available for this machine learning and AI based strategy. Advantage, adaptive, can handle the real-time variation and uncertainty. Yes, once you train the model, then it will accept any condition. Limitations, require the large training data, higher computational requirement, because here is more data, huge amount of data. So it is required the higher computation power. Last one, there is a hierarchical power management. Divide the control into the layers. So there is a step-by-step process. So high level, mid level, low level, correct? So there is a step-by-step process, and then you can able to manage the power. Advantage is scalable and modular. Limitation, design the complexity, because you have to design the level, maybe the high, maybe the 5 level, maybe the 6 level, maybe the 10 level. So depend on the complexity of the system. So these are the 5 strategy to manage the power. Okay. So key point from the today's class. So there is a energy management strategy, automotive. So sorry. So this is gonna switch over the slide. So key point from the today's class. So key function of the block diagram of the power, EV power management, and type of the power management strategy. So from the next class, we will study the energy management strategy for the automotive networking and communication. So basically the communication. So what type of communication we are using for the automatic networking, and EV charging standard, there is a V2G. So basically vehicle to grid, grid to vehicle, vehicle to business, vehicle to any, correct? So any, so this two component we can say V2X, correct? And this one is vehicle to grid or grid to vehicle. Okay, so these two topics we will discuss in the next class. So now any confusion, any query from the today's class? Yes, any query?
Sir, in power management, how we can practically manage the power
Practically means?
for just thinking about one optimization strategy?
Mm-hmm.
What we make objective function and what are the constant for maximize or minimize the power management?
Yes.
How can we identify the constant and what is our objective?
Yeah. So suppose I can consider the simple example. Suppose I have a battery, correct? And from battery we have to give the power to the your motor. So maybe suppose we are considering the PMSA motor, and we have to manage the power, correct? So now in the initial stage, what type of parameter we are considering, correct? So for the battery, state of charge, that is the most important part. State of health, that is the most important part. And state of charge, state of health, and maybe the state of discharge, SOD. Yeah, maybe the temperature parameter. So suppose you are considering these 4 parameters: state of charge, state of health, state of discharge, and state of temperature. Suppose you are considering these 4 parameter and you want to manage the power. Okay.
Yes, sir.
So now what is the target for us? Otherwise, what we have to do to manage this power for battery? So first thing, how much power demand to the your motor? Okay, how much power is demand to your motor? So that is the
Yes.
first thing. Second one, is it possible whatever power is required to your motor, is our batteries deliver that power? Suppose yes, condition is yes, yes, it is possible to deliver the battery power to the motor. Now we have to manage the power. So what we have to do? So we have to check the condition of the SOC, SOH, SOD, state of the discharge, and state of the temperature. So based on this parameter, we can transfer the power. Suppose your SOC is not very good, then you are not able to transfer the power. Suppose your temperature is continuing increasing while delivering the power. Still, you are not able to deliver the power because your temperature is continuing increasing. So you have to come down your temperature. So you have to increase the cooling system in your vehicle. And second one is the depth of discharge. Your battery's depth of discharge is too much below the average level. Still, you are not able to deliver the power. Correct? So this type of parameter we have to consider in our control algorithm. Then we are able to manage the overall power of the system. Got it?
Yes, sir.
Yeah. So that's why I said, so one by one we have to see the condition. So so we can say normally we can say it is a two heart in the electric vehicle. One is a battery and another one is a motor. Correct? So
Yes.
we have to take care of the every parameter. Yes. Good question. Any other query?
If, sir, our vehicle is moving to uphill, then suddenly it requires a high amount of power. Then, if our all parameters are very low, poor, and then how our system will manage this power? Or how
Then you are
our vehicle.
then you are not able to climb up. Your vehicle is maybe the stop, yeah, maybe the stop down, maybe the coming down.
Then that condition, how we manage, how we can rearrange or change our algorithm.
Then we don't have any option. We have to charge our vehicle because we don't have a sufficient energy, correct, in the battery.
Yes.
Correct. So you don't have sufficient energy in the battery. Then how you can suppose you are applying any algorithm, but minimum energy is required, correct, to work on any algorithm. Suppose you don't have any minimum energy in the system, then your
Sir,
control algorithm is not work.
Yes, sir.
regenerative braking action works or not, sir, in this situation, sir?
So that is a depend on the design of the algorithm. Suppose I am design the algorithm, there is a power management, and suppose I integrate this regenerative energy with my power management, then it is working fine. And suppose I cannot integrate this regenerative braking with my power management, then it is not working. Obviously, regenerative braking is applicable on the hilly area, correct? So suppose you are going down to up area. So that time you are sorry. Suppose you are coming from up to down area, so you are applying the brake, correct? So that time regenerative is applicable, and it will generate the energy. But suppose in your power management system, you are not giving the any signal to the regenerative braking, then it will not work combinedly, that power management and regenerative. But in the 90% case, regenerative and power management both are the correlated to each other. Correct? Only 10% is there. So both are the no correlated. Otherwise, 90% case, regenerative energy and your power management both are the correlated to each other. Got it, Suraj?
Yes, sir. Okay, sir.
Yes. Yes. Any more confusion? Any more query? Yes. Anybody see the practical scenario of the regenerative? Maybe you drive the vehicle in IC engine normally we are not doing, but in the EV normally we are doing. Any practical experience you are able to see the regenerative energy? You can drive your vehicle and suddenly it will generate the energy and you can see it. Any practical experience to any student? No. Maybe you can drive your vehicle. Suppose you have an electric vehicle, and then you can come down from hill area, and then you can give the brake. But before doing that, you can see if your regenerative braking is applicable, yeah, no, in your vehicle. Correct. Then you will get it. You can charge your battery. So normally in the electric vehicle, regenerative braking is directly going to the battery. Correct. So if you have time and you can somewhere going to visit for picnic, and then that time you can check the regenerative performance. Okay, good. Any more confusion, any more query from the today's class? Okay, if no query, then we can stop the today's class, and tomorrow we will meet for the next topic, that is a V2G, G2V, and communication for the charging protocol. Thank you so much.